Hi there. Here we're going to try to rewrite f of x equals x to the sixth minus 4x to the fourth plus 3x squared minus 12 as f of x equals some quotient times x minus 2 plus r. So recall that this x minus 2 means that really we need to go divide by x minus 2, figure out what the quotient is and what the remainder is, and that's what's going to allow us to rewrite it in this form. So for the purposes of this example, let's use synthetic division to see this. So if we divide by the quantity x minus 2, that means it's like putting 2 in the cubbyhole, and then we need to put all the coefficients of the polynomial f of x, which would be 1, 0, negative 4, 0, 3, 0, negative 12. Because remember, for example, there's no x to the fifth term, so we need to put a 0 to keep that place for us. So now, if we do our synthetic division, we carry down the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 3 plus 0 is 3. 2 times 3 is 6. 0 plus 6 is 6. And 2 times 6 is 12. Negative 12 plus 12 is 0. 0? So that means that there was no remainder. That means our remainder is 0. Awesome. Okay, so that means that when we want to rewrite our polynomial, let's put this one in green, we can now rewrite our original polynomial, which was x to the sixth minus 4x to the fourth plus 3x squared minus 12. We can rewrite this as the quotient coming from these pieces. So it was a sixth degree polynomial, so now it would be x to the fifth plus 2x to the fourth plus no x cubes plus no x squareds plus 3x plus 6 times the quantity x minus 2. And I guess I should have left space here to put the plus 0, but really putting the plus 0 is redundant because it means that there was no remainder. Okay, don't forget, let's do this in red here, that if we wanted to verify that that was the right remainder, because remember, sometimes we make errors here, right? If we're going to take f of 2 by the factor theorem, we would expect this to yield 0. So let's make sure we're on the right track here. So f of 2 would be 2 to the sixth minus 4, 2 to the fourth plus 3, 2 squared minus 12. 2 to the sixth is 64. 2 to the fourth is 16 times 4 is 64. 2 squared is 4 times 3 is 12 minus 12, and look how convenient that is. 64 minus 64, 12 minus 12 is 0. So we can see that the remainder we get due to the factor theorem is the same as the remainder that we got at the end of the division problem is the same as the remainder that we got from the synthetic division.